All right, guys, what we're looking at here is a question from 2015. It's the graphical analysis, and like all other graphical analysis problems, you don't get to use a calculator on this one, and that's okay. So let's just, I guess, dive right in and see what's going on in this problem. So this one is a little bit different than some of the other graphical analysis problems that we've seen in the past, just because there's actually some context. It says the figure above shows the graph of f, the derivative of the twice differentiable function, or f prime, the derivative of the twice differential function f on this interval, so from -3 to 4. The graph of f prime has horizontal tangents at -1, +1, and x equals 3. The areas of the regions bounded by the x-axis from -2 to 1 and 1 to 4 are 9 and 12, respectively. So it's telling us the area, it's telling us where this graph has maxes and mins, so it actually tells us more information than we usually get on a graphical analysis problem. So let's take a look at letter A. Letter A says, find all coordinates at which f has a relative maximum, give a reason for your answer. Well, remember, in order for us to have a relative maximum, the derivative graph has to change from positive values to negative values. And that happens once at x equals -2, so that's our answer, and the reason for that is f prime changes from positive to negative. And that's it. That's all you have to say. A lot of people think that there might be one at x equals 4. The problem is because it ends at 4, we don't know for a fact that that's going to be a maximum. The graph could bounce back down like that, then it wouldn't be a maximum, so we can't say that that one is for sure. So that's our answer for letter A. Letter B wants to know where is, between -3 and 4, is the graph of f, so the original function, both concave down and decreasing. So let's talk about each of those things. Let's do decreasing first. In order to tell where the graph is, the original function is decreasing, we have to look at the derivative graph and see where it is below the x-axis. So we can see from x equals -2 to x equals +4, my original function is decreasing. Now, where we tell that the original function is concave down is we look to see where the derivative graph is actually decreasing and on what interval. So I can see from -2 to -1 it's decreasing. And I can see from 1 to 3, it's also decreasing. So what my answer is actually both of these. Since the graph is below the x-axis the entire time, this is where it's also concave down. So concave down and decreasing, I'm looking for both of those things. Hopefully that, again, that kind of makes sense. We have to look for both of them happening at the same time. Okay. The third one, find all x coordinates of the point of inflection. Well, on every AP test, of all of the AP test questions I've seen, it's almost, I don't want to say ridiculous to me, but they actually give you the answer to this problem in the explanation. At x equals -1, at x equals +1, and x equals 3, that's where we have, where f prime has a max or a min. That, anytime we have a max or a min on the derivative graph, that means that the second derivative is equal to 0, which means we have a point of inflection on the original function. So again, pretty easy on that one. This is what, again, I think this is one of the easier problems I've seen when it comes to graphical analysis, as long as you know your vocabulary and what you're looking for. Letter D says, given f of 1 equals 3, write an expression for f of x that involves an integral. What this is asking us to do is it wants us to write some sort of expression that has an integral in it. This piece of information they give us right here is like an initial position. So I put a 3 right here, and then remember, when we have an initial position, wherever that occurs, that's what goes at the bottom of the integral. This wants us to figure out what the position is just in general. So really we would put like an x right there, and then I would just say this is f prime of t dt. If you skipped that step and went right to either one of these, you're actually good to go. So basically what we want to do is I'm going to find my position when x equals 4. So I've got the integral from 1 to 4 of f prime. And you could have used x here. T is technically the right letter. The nice thing about this is I know that the area from 1 to 4 is 12. Since it's below the x-axis, I would have like 3 minus 12. That would give me -9. And I would just have to do the exact same thing for this one right here. The difference here is we are moving backwards. So in order to get this right, technically I have to flip this upside down. So I get the integral from -2 to 1 of f prime of t. And that integral, -2 to 1, again, we know that this area is 9. It's below the x-axis, so this is like 3 minus -9. That's the same as 3 plus 9, which gives us 12. That is our other answer for this problem. So again, I thought overall this one was pretty easy. Letter D is a little bit tricky, but not real bad. So if you have any questions about how to do this problem, please let me know.